This is a video for the final review in my Calculus 2 class. The directions say to evaluate each integral. Let's take a look at example 1. Suppose we have the integral of x squared arctangent x dx. I'm going to integrate this by parts. So what we're going to do is let u equal arctangent x. du is 1 over 1 plus x squared dx. dv is x squared dx, and v is 1/3 x cubed. So the integral of x squared arctangent x dx is equal to 1/3 x cubed arctangent x, that's uv, minus 1/3 the integral of x cubed over 1 plus x squared dx. So in other words, we're subtracting the integral of v du. Now, I'm going to rewrite x cubed as x squared multiplied by x to the first, essentially. So if we look at the next page, this is equal to 1/3 x cubed arctangent x minus 1/3 the integral of x times x squared over 1 plus x squared. And so notice how I section off x squared over 1 plus x squared. I want you to focus on just this piece. Now, if we come to the corner here, we can take x squared over 1 plus x squared and write it as x squared plus 1 minus 1 divided by x squared plus 1. If we split the fraction, this is equal to x squared plus 1 over x squared plus 1 minus 1 over x squared plus 1. But this is equal to 1 minus 1 over 1 plus x squared. And so if we go down here, we get 1/3 x cubed arctangent x minus 1/3 the integral of x, right here, multiplied by 1 minus 1 over 1 plus x squared dx. If I distribute the x and then split the integral, we get 1/3 x cubed arctangent x minus 1/3 the quantity, and then we get the integral of x dx minus the integral of x over 1 plus x squared dx. Now, from here, this is equal to 1/3 x cubed arctangent x minus 1/3 times 1/2 x squared plus 1/6 the natural log of 1 plus x squared plus c. And so my final answer, again, is 1/3 x cubed arctangent x minus 1/6 x squared plus 1/6 the natural log of 1 plus x squared plus c. So again, I want you to notice I distribute the negative 1/3 inside to each integral. And remember, a negative times a negative is a positive. And so if you need that extra step, that's fine. Just remember, we get 1/3 x cubed arctangent x minus 1/3 the integral of x dx plus 1/3 the integral of x over 1 plus x squared dx. And then this line follows very well, and then hence the answer. And this is example 1. If we take a look at example 2, we have the integral from 0 to pi over 4 of x sine x over cosine cubed x dx. So this is the integral from 0 to pi over 4 of x times sine x over cosine x times 1 over cosine squared x dx. And so sine x over cosine x is tangent x. And so, and also 1 over cosine squared x is secant squared x. So this is the integral from 0 to pi over 4 of x times tangent x times secant squared x dx. And this is another by parts problem. I'm going to let u equal x. du is 1 dx. dv is tangent x secant squared x dx. And v is 1/2 tangent squared x. And so remember the uv minus the integral of v du. So this is 1/2 x tangent squared x evaluated from 0 to pi over 4 minus 1/2 the integral from 0 to pi over 4 of tangent squared x dx. Now, if I replace x with pi over 4, I get 1/2 times pi over 4 tangent squared of pi over 4, essentially minus 0, right? And then I'm going to go minus 1/2 the integral from 0 to pi over 4 of secant squared x minus 1 dx. Now, remember that tangent of pi over 4 is 1. And 1/2 times pi over 4 is pi over 8. So this is pi over 8 minus 1/2 the quantity. And then it's tangent x minus x, right? So in other words, the integral of secant squared x dx is tangent x. The integral of 1 dx is x. So again, we get pi over 8 minus 1/2 the quantity tangent x minus x, evaluated from 0 to pi over 4. So this is pi over 8 minus 1/2 of 1 minus pi over 4. So again, tangent of pi over 4 is 1. That's where I'm getting that. So if you want, we get pi over 8 minus 1/2 of 1 minus pi over 4, like so. And that's basically what I wrote there, right? And so you get pi over 8 plus pi over 8 minus 1/2, which is pi over 4 minus 1/2. Or if we get a common denominator, the LCD between 2 and 4 is 4. So I put a 4 in the bottom, and on top we get pi minus 2. That's another very acceptable way to write that problem. And I'll give you one. I'll just throw in a trigonometric integral here. So if we have the integral of tangent to the 4th x plus tangent squared x dx, this is the integral of tangent squared x times tangent squared x plus 1 dx. But this is equal to the integral of tangent squared x times secant squared x dx. And I'm done. So this is 1/3 tangent cubed x plus c. So keep in mind, in my mind, right, remember that the derivative of tangent x is secant squared x. So I'm already thinking that this is the integral of u squared du, right, which is 1/3 u cubed plus c. But remember, u is tangent x, and hence this is where I'm getting this from. Okay, so that'll do it for this video. And this is for the final review. We did 2 examples of integration by parts, and then an example that involved trig. So, okay, thank you.